friends, myself Hemant M. Patel, Assistant Professor, Mechanical Engineering Department, Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Today we are going to discuss about the steam nozzle. First of all, the introduction of the steam nozzle. Generally, we are utilize the nozzle for the increasing the uh, velocity of that particular fluid. Okay, so generally we can say like that nozzle is a duct. So over here you can see nozzle is a duct by flowing through which the velocity of fluid increase at the expense of pressure drop. If the fluid is steam, over here you can see, if the fluid is steam, then the nozzle is called as steam nozzle, right? The flow of steam through nozzles may be taken as adiabatic expansion. The steam possesses a very high velocity at the end of the expansion, and the enthalpy decreases as expansion occurs, right? So over here you can see very high velocity steam we are getting at the end of the expansion, and enthalpy will be decreased. The major function of nozzle is to produce steam jet with high velocity to drive a turbine. Generally we are introducing this nozzle for the getting the high velocity, and through the high velocity we can rotate the turbine. Friction exists between the steam and the side of the nozzle. Heat is produced as the result of the resistance to the flow. The phenomenon of supersaturation occurs in the steam flow through the nozzles. This is because of the time lag in the condensation of the steam during the expansion. So first of all, the basic thing for which we can utilize the nozzle to increase the velocity of that particular fluid. The area of such duct having minimum cross section is known as the throat. So in nozzle, we will discuss later about the types of the nozzle. So in between this type of thing, throat is coming. A fluid is called compressible. Over here you can see a fluid is called compressible. Means what? If its density changes with the change in pressure brought about by the flow. If the density changes very little or does not change, the fluid is said to be incompressible, right? So suppose density which is not change at a time, the fluid we can say like that it is the compressible. Generally the gases and vapors are compressible. We can compress that particular fluid, where liquids are incompressible. Okay, so over here you can see types of nozzle. There are generally three types of nozzles: convergent nozzle, divergent nozzle, and the third one convergent divergent nozzle. So over here you can see this is the convergent section, divergent section in between the throat, right? So this is the convergent section. From the entrance to exit, the cross sectional area will be decreased. This is the throat, and after over here you can see divergent section. So from here the cross sectional area will be increased, right? So from the entrance over here you can see high pressure low velocity gases we are introducing into the nozzle, right? So from getting after the conversion low pressure high velocity gases, right? So velocity will be increased through the nozzle. Okay, so this is the basic things. This is the subsonic, supersonic, and we can select this is a sonic. So Mach number 1, right? Subsonic, sonic and supersonic. This is the conversion nozzle. In a conversion nozzle, the cross sectional area, right? Already we have discussed, cross sectional area decreases continuously from its entrance. This is the entrance and this is the exit. So cross sectional area will be decrease. It is used in case where the back pressure is equal to or greater than the critical pressure ratio. This is the diversion nozzle. Over here you can see the cross sectional area of diversion nozzle increases. So from here the cross sectional area which is increasing from the entrance to the exit, right? So the cross sectional area of diversion nozzle increases continuously from its entrance to exit. It is used in case where the back pressure is less than the critical pressure ratio. And this is the third one, conversion diversion nozzle. In this condition, the cross sectional area first decrease from its entrance to exit. So entrance to the throat, this is the throat in between, and then again increase from throat to exit. So this is the conversion, this is the diversion, and this is the throat, right? Over here you can see conversion region, diversion region, and throat. So this case is used in case where the back pressure is less than the critical pressure. Also in present day application, it is widely used in many types of steam turbine. Right, so generally right now in widely recently this type of conversion diversion nozzle utilized in many types of steam turbine. Okay, what are the effect on friction on nozzle? Right, so entropy increased, the energy available decrease, velocity of flow at the throat get decreased, volume of flowing steam is decreased, throat area required to discharge a given mass of steam is increased. So these are the effects of friction on nozzle. So this type of three types of nozzle, conversion, diversion, and throat. Okay, this is the subsonic velocity over here. This is the subsonic velocity, supersonic, and sonic velocity, right? So over here Mach number is equal to 1, less than 1, and greater than 1. Okay, so from here low velocity, and we are getting at the axis high velocity. So generally we can say like that we are using the nozzle for getting the high velocity. And these are the effect of friction on nozzles, right? Thank you.